Hey guys, so today we are not in our usual setup. We have come up here to see the Mercury's transit. So I have here my telescope. It's a 6mm Newtonian reflector. So there's still time for the Mercury transit to occur. So let's talk about the telescope for a second and how it works.
Think why we can't see distant objects for a second. The tiny opening of our eye does not allow enough light to come inside our eye and hit the retina. So the faint distant objects make a very tiny image in the back of our eye. That's why we cannot see distant objects clearly. So what does the telescope do here? A telescope can be compared to a water bucket, only that it collects light instead of water. The huge openings in the front of the telescope allows more light than our pupil to enter the telescope. All the amount of light is then concentrated to the eyepiece. In a reflected telescope, it is first reflected from a mirror that is in the back of the telescope and then to a secondary mirror and then to the eyepiece. In the eyepiece there is a magnifying glass that we call the lens, which concentrates all the light and magnifies it so that we can see a sharp magnified image of the objects that we are looking at, like the stars, the galaxies, and even the planets. In a refractor, in the front of the telescope there is a lens which collects all the light and converges it to the eyepiece, where there is another lens to magnify it. That's why the bigger the telescope, the better you observe.
Observing the sun with naked eye is very dangerous because the sun rays can damage your eyes, can cause permanent blindness. If you have a telescope, you need a solar filter for it, or else please don't observe it. So this is a solar filter that I'm using for my telescope. I'll show you the footage that I've collected throughout my observation.
It was so beautiful. So the tiny dot that you can see here is the baby planet Mercury. And this dot, it's a sunspot. Looking at this picture gives you a feel of how big the sun is and how small the planet Mercury is compared to the sun. The sunspot on the sun is bigger than the planet Mercury. So sunspots are temporary phenomena. They appear on the sun as dark spots compared to the surrounding region. They are caused because of the concentration of magnetic field in that region, which in turn causes reduced surface temperature compared to the surrounding area. So I was thinking, how large can a sunspot be? There are many sunspots that are larger than the planet Earth. Once in a while, huge sunspots the size of a Jupiter show up on the surface of sun. Looking at the sun in action is wonderful. If you ever get a chance, please observe it. If you have a telescope, go out, use a solar filter and watch the sun. I'm telling you, it's not at all boring. Sun is always active, having its sunspot, blasting out solar flares, every sort of thing. Is so beautiful. So while I was observing Mercury's transit, I was thinking we can also see it from other planets. And we have our rovers on other planets. So I searched online and I found on June 3rd, 2014, Mars rover Curiosity observed the planet Mercury's transit. Mercury's transit happens 13 times every century. I even had another thought. When we start living on Mars someday, people there will see an Earth transit, which will be jaw-dropping, I guess. When you see Earth from Mars, you will see how small we are compared to the sun. To see our own planet in motion around the sun will be wonderful. While planets transit their star, it's a very good time for scientists to study the atmosphere. And that's why transits are important for scientists.
And as always, stay curious, stay awesome.